This conference will now be recorded.
Yeah, so yesterday we have discussed about I started sharing my screen. Yesterday we discussed about Kafka's producer API. Uh, so how many of you, okay, second yeah, how many of you tried that examples? Rishabh, I think you were trying to install. Any luck?
Yeah, actually, I was able to install it, but I was doing my Hive queries.
Okay, let me start. Let's see today the consumer. Okay, so yesterday we have seen like simple producer and the keep on sending the messages which are consuming in the consumer. That's the consumer. For consumer we have seen. So we have now defined a consumer API. So let's start today a consumer API and let's see how it will be, how it will read the how it will read the data from producer and how it will process it. Okay. So can anyone tell me what is a consumer? How it will work? Because this is the frequent question in interviews people will ask. What is the consumer? How it will work?
Consumer is
Consumer.
a machine
Yeah.
which subscribes to a topic.
Consumer is any application like Java application or a Spark application who can subscribe to Kafka topic and read the messages.
Okay. Okay. Yeah, Rishabh, there is a background noise from you, Rishabh. I don't know whether it is your mic or something. A lot of background noise is there. Go ahead, Prabhu. I was saying something.
Consumer is any application, for example, Java or Spark application who can subscribe to Kafka topic and read the messages.
Okay. So a consumer is an application who will subscribe to the Kafka topic and will start to read the messages and process. What is the current offset and committed offset?
Until which offset the consumer is processed, that offset is called current offset. No, committed offset. Whatever the messages producer send to send the end message is called current offset.
Okay. So whatever the messages the consumer is processed, let's say I have a 20 messages has been published, till 15 messages it has been processed. 15 is my committed offset. Okay, and 20 is the current offset because it is publishing. Still it is publishing. It's not yet completed, right? So that is committed offset. Sorry, that is the current offset. 20 is the current offset, and 15 is the committed offset. Okay. So any other doubts? Any other doubts before we start a consumer review? Any
I'm good,
questions?
Ravi.
Okay. Let's write our consumer, a simple consumer. Then we'll start with the data from same as your producer only. It also requires its own main method because it's an entry to the consumer application. Okay. Then we need same kind of properties, but the properties will change, not exactly same. We need to create a properties here also, but some properties will change. Okay. What are the properties is required here? Can anyone tell me what the to connect
Connect to the Zookeeper.
we need a bootstrap server. Okay. Yes or no? We need a bootstrap server, and we need a here we did the key serializer, right? We did the key serializer. We need here key deserializer. We need a key deserializer, not the serializer. Okay. So I missed one point here. Here producer config we did no. Instead of producer config, we have to do consumer config. Look at here. Consumer config. I click on this. These are the consumer configs. Group ID. What is the group ID? Some information. Whole interval, some other stuff will be there here. Okay. So I need to make use of consumer config. What's server ID? Deserializer. This is same. This is same. Here, instead we use string serializer, we'll go with the string deserializer, nothing else. String deserializer. Similarly, consumer config value deserializer. Value deserializer. So also string deserializer. And we need two more properties. What are they? They are They are group ID and topic. Which topic I need to connect, I have to tell, right? I need group ID, which group we're going to connect. Last time we have created one. Let's connect to the same group. Oh, I think now we are keeping the new one, right? I think yeah. So the older one will not work. Let's take a new one. I'll say group one because I have removed that log directory. I changed the log directory due to some issue. So I'll take a new one. And so now group ID. What else we need? Topic. We need topic. We can directly read from the topic. We don't really need to specify this. Which is enough. Yeah. Let's put this to connect the Kafka. Now, how we have a producer, Kafka producer, we have something called Kafka consumer also. Why I'm comparing, so you will easily understand. Okay, that's the reason. So how we have a Kafka consumer and Kafka producer, we do have a Kafka consumer. Kafka consumer. Your Kafka consumer also reads the string, right? Okay, consumer. Same. Who will take the properties? Okay. Once your Kafka consumer is created, what we need to do? We just need to read the messages. So to read the messages, he has to subscribe to Kafka, right? He has to subscribe to the Kafka. So creating Kafka consumer is not enough. He has to subscribe to the Kafka. So how to subscribe Kafka? Consumer dot subscribe. Consumer dot subscribe. Here we will give topic. Here it can be single topic or it can be multiple topics. So we will give arrays as list because we are connecting to multiple topics. It has to connect multiple topics. But we are giving single topic, but it can give single topic in this fashion also. The topic is yesterday what the topic created. Topic -1 only, right? Because I want to connect the same topic. Topic -1. Okay. Now done. I have created Kafka consumer. I have subscribed. I need to read it. How will I read? I will just say to read it has to keep running. So to keep run, what we will do? While true means it will keep on running. So how you have a Kafka record here, produce a record here because you are sending a record by record. Here also we have a consumer record. Kafka consumer record, right? Consumer record, consumer record. So this consumer record also string to string, comma string. The record consumer dot poll. Poll is nothing but polling. It will connect and start read the data. Okay. Here we need to specify how many milliseconds. It has to go and connect and read the data, right? So what is the default? So I'll just do some millisecond. We can do like this. If you press Control Enter, you can directly specify here duration dot of millis. Here, how many milliseconds? Change variable record type to record, and this is the language. Okay. Then once you read the messages, that messages we will just print in the console. Just print in the console. So let's say we print such a way that we print a message, right? List of messages. It will not read one line. It may read a collection of messages. For that, we will take a consumer record. Let's say this is records. I'm looping through the collection of records, nothing else. Okay, I'm just trying to loop through collection of records. Required kind consumer records. Consumer record.
Above, after the while true consumer records should be record.
Sorry.
While true, then consumer records, it should be record.
Yeah, this is records and this is record. Correct.
Okay, this has to be.
No, the first one is record. So you'll get a lot of records in it. The second one is
Okay.
this is just a record. One record by record I'm taking. Good here. Okay, let's see what we have read from here. It's a key. It's a record dot keys. Record dot key. Then value. Record dot value. it will read partition also. See which partition will read partition. And offset also we can take. Search. Dot offset. Topic also we can see which topic it is created. We will take that also. Because if you connect to multiple topics, you can also print which topic it is connected. But here we're connected with single topic, we really not required, but still let's do that. I'm done with it. Properties. Let's go ahead and run this program. But before we let's consumer the first. Let's consume. Okay, before run this one, my Kafka should be up and running. So let's go ahead and start it. C18. Here I need to start. Properties. It started running. Let's run our simple producer. It only sends one message. It only sends one message. Let's see how our consumer connected. Got the message. Key is null. We are not sending any keys, right? We are not sending any keys here. See, we are not sending any keys. Directly we are sending a value. That's the reason. That's the reason the key is null. And the value is I welcome to the custom producer. It's a partition 0. And offset is this. Topic is this. Okay. So let me close this producer. My consumer is still running. Okay, consumer is still running. Let's start another consumer, sorry, another producer who sends multiple messages. Okay, welcome to custom producer messages. Message 1, message 2, like that little thing. Okay, Here can have some delay, and instead of 2000 messages, I just send 200 messages. I send 50 messages. Just send it. Just run the producer. My producer is running. Why it is not sending messages? Oh, here I'm not printing anything. I'm just sending the messages. Here I'm receiving the messages. You can see. So here, whatever the topic I'm making use, it has only one partition, and it is just reading the messages, and keys are null. That's the reason. It's always go to the single partitions. Look at here. It says 37, 40, 44, 50 messages is sent. Producer send the messages and success. Let me close this as well. Let me start asynchronous producer. Where it is sending to a topic 2. It's a different topic. It's sending to different topic, and messages, message 1, message 2, message 3. So now I need to specify the topic 1 here I have given. So I will specify topic 2. When I change the topic 2, I need to restart. I can stop it here. I can do the restart. My consumer is started. Now let's send the messages. This one. You can see here. Here also key, we are not sending the key. I'll show you one example with the key. Key null, message 0. It went to partition 2. Offset is 17. It's sent the next, the topic is that. And key is null, message 1. Start, because it starts from 0. It went to partition 1 and topic 2. Next, message 2, partition 0, and this. Okay. So round robin fashion, it's sending the messages, and in the same fashion it's consuming the messages also. The same fashion it's consuming the messages also. It's sent the same pattern. Okay. Any questions? It's here showing the key is 0, right? Key is null, not 0. Key is null, right? You can just send. Okay, you can just add your key in your producer record. You can just add your key in your producer record. I can just say here. Yeah. Anyway, I have and say partition record then value key I because when I go to a producer thing, when I go to a producer class, you can see different constructors are there. Different constructors are there. Those constructor. This is the constructor I'm using now. I'm sending topic. I'm sending key. I'm sending value. This is one constructor. Similarly, you have different constructors. Topic, partition, key, value. This is one constructor. You can specify which partition the data has to go. And this is another constructor. Topic, partition, key, value, and some headers. Some specific header is specified. It will go to respect to topic. Respect to partition it is. So like that, you have a different constructors are there. Okay, topic, partition, timestamp, key, value, headers. So you have a different kind of constructors are there. So we are using simple asynchronous. We're just using this. Okay, you can give anything here. I just given the key. You can give anything. You can say my key. Anything you can give. Okay, it's not like you have to give only. You can give ID also. Feel that ID also you can give. Okay, ID underscore one, ID underscore one. So different keys will give. I think I need to read more. Let's run my consumer. Consumer is already running. Okay, two consumers I start. Okay, two consumers I started. Let's send the message. Consumer one. It should not be null in this case. 14. Okay. 13. We got 11. 13. Where is the 12? It's here. 9, 10, 12, 14, 13 went there. 16. One after one it is printing. Okay, here 17. Let me show you the bottom last one. Oh, how many messages? Message 50. So 47. Message 47 it is taken, and message 50 it is taken. What about in between? And 2. 49. You can also see partition 1, partition 1, partition 0. It means the first consumer is dealing with the two partitions. This consumer is partition 2, partition 2, partition 2, partition 2. This is always connected to partition 2. Okay, let's start one more consumer. Let's start one more consumer. The same instance, same. So you're not going to do any change, right? You are calling the same consumer only. You are calling same consumer because you're running the same consumer, because we really see that's what the consumer group means, right? Same consumer will be there in the same consumer instance will be there in the consumer group, right? So the process and everything should be same. So I'm launching one more consumer. Launching one more consumer. Three consumers. Let's start a producer now. One second, let me clear this. I think I can clear. Now all are okay. Let me send the messages and see how it will go. And also, since I have a key here, so based on the key, it is not go round robin fashion this time. It will not go round robin fashion. It will go based on the key. It has a key. That's the reason it will go by hashing algorithm. It will take the hash code modulo by number of keys. So number of consumers. It will go that way. Producer. So you can look at here. This is connected to the partition 1. It's connected to the partition 2. It's connected to the partition 3. Okay, you can see message 6 it is dealing with. Okay, you can see message 1 it is taken the last consumer, first consumer, the second consumer is taking the message 2, and the first consumer is taking the message 0, and the now message 8 it is. So what about in between? 7 messages are missed. Where are they? So it is taken 5, 4, 5, 7. It's not round robin fashion this time, right? I hope you guys are able to understand this. This time it is not round robin fashion, right? It is based on the keys it is sending the messages. Any doubts so far? Any doubts? Yes, no? Are you guys able to follow?
Yes, Ravi, no doubts.
So this is with a simple consumer. Okay. So this consumer, here also I can show the consumer group itself. The same only this one consumer group. I have launched multiple consumers and they started reading it, and they started the processing the data. Okay. So this is how we will publish the keys. I mean, this is how we publish the messages with the key, and this is how we'll read the messages from here. The consumer. They'll be keep running. The producer is completed sending the messages. So that's how the consumers will keep on. Why it is, since I have uh, written inside the while loop. So that's the reason they will be keep running. Okay, now let's talk about how the producer internally works. How the producer internally works. Then how the consumer also internally works. We'll discuss that. If you see the producer, you take synchronous or asynchronous, whatever. Even you can take the simple producer. So I will show you one more example. I will start the different consumers. Okay. After starting the different consumers, if I close in one of the consumer in middle, so what will happen? Other consumers should be able to connect other partition, right? And that also let me explain that. Let's connect to my pin pad. Look at here, guys. The producer, what actually we're doing? First, we're creating property. Yes or no? First, we're creating property, right?
Yes.
After creating properties, what we are doing? We're creating consumer. Then consumer, sorry, producer. First, we're creating a properties, then producer record, then we're publishing the messages. Then we're publishing the messages. Okay. Let's look at how it will work internally. First, you have taken your set of properties. What is this properties? What is this properties? What is my is key deserialize, what is my key serialize, what is my value serialize, what is the bootstrap server, what is the topic we are anyway setting in the producer record. Topic anyway we are setting um, in the producer record we are setting. So other properties like a bootstrap server, your key serialize, value serialize, these properties were actually specifying in the properties. Those, with the help of those properties, we are connecting to the Kafka producer here, right? So if you look at this closely, so what is happening here is first we have created the props. The properties are something like our bootstrap server. Then we are sending to producer record, producer actually, not producer record, producer. So with the help of this producer, we are just trying to uh, we're trying to connect to Kafka. This is my Kafka. Here, this producer helped creating a producer record. Producer record. This producer record uses the key serialization, value serialization, the stuff anyway it will be there here. Okay, so this one actually what it does, with the help of the topic, um, it will start collect the data. I can say buffer. Here is taken your properties, collected the properties is sent to a producer. The producer created a producer record. The producer record has a topic name. Topic, what are the messages you are producing here? It will buffer for some time. It will buffer. It will not send as soon as you send the message. It is not the direct what you see in the console consumer or what in the application. In application also you are sending the message, but in a few milliseconds it will buffer the messages. That's called linger messages and milliseconds. Actually, we collected some properties, right? Okay. Let me show the message. Patch up. For the patch. Yep. KAFKA. This documentation. Producer. Supplies value serialize. ACKs. We will see one example of the ACKs also. Buffer memory. Okay. Look at this buffer memory. The total bytes of memory producer can use to buffer records wait to send to the server. If records are sent faster than they can be delivered, the the producer will either block or withdraw an exception based on the block buffer is full like that. Okay, this setting should correspond roughly to the total memory of the producer will use, but it is not hard bound since not all memory the producer uses used by buffering. some additional memory will be used to compress if you have a compression. The compression is enabled. It's not by default. So that what I'm trying to explain here is there is something called buffer memory. The messages whatever you send, it will buffer it before it sends. It buffer it before it sends. Okay, and this is a compression. There are different kind of compressions in Hadoop. bzip, gzip, snappy, lzo, lz4. There are different kind of some compressions are there. These are the different compressions supported by your Kafka. Apart from retries, what is this retries? Let me explain you. Yeah, now you understand the buffer, right? So there is something called some milliseconds also. This is the batch size I was talking about. So what is this batch size? Look at it here. The producer will attempt to batch the records together into fewer requests. Whenever the multiple records are being sent to the same partition, this helps the performance on both the client and server. The configuration controls the default batch size in bytes. No attempt will be made to batch records larger than its size. Records sent to the broker will be contain multiple batches, one for each partition with the data available to send. So instead of sending one message, it will send set of messages. It leaves set of messages to send. So a small batch will make batching a less common and may reduce throughput. Throughput means the kind of performance I mean to say. Okay. Next, let's look at it. The client ID, connection max, idle. So how much time the connection can be idle? Not this one. There is something called linger milliseconds. This one. What is this linger milliseconds? Let me keep it in. Maximum block milliseconds also. You can read these properties. You can actually get more information. The producer groups together any records that arise in between the request transmission into a single batch request. Normally, this occurs only under load when records arrive faster than they are sent in. They're actually one of the messages sending to the Kafka, right? If you are sending more faster than it is received. Receive in the sense if Kafka receives, not the consumer. Consumer is only when he want, he will subscribe and he will read. So here the server means you should not consuming or receiving means you should not think that it is a consumer. You should think it is your Kafka. Client is nothing but your producer. Okay, consumer will not come into picture here. Consumer when he is interested, connect and subscribe and read the message. That is different. However, in some circumstances, the client may want to reduce the number of requests even under the moderate load. The setting accomplishes this by adding a small amount of artificial delay is that. So I'm keep on sending the messages and your Kafka is not reading that much fast. So what it does, it will keep the batches. So to create that batch, how much time it has to wait? So what it does, rather than immediately sending out the records to the producer, wait up to the given delay to allow other records to be sent, so that the sends can be batched together. This can be thought of an analogies to the some algorithm. I'm not really sure what is this algorithm. This setting gives the upper bound and delay batching. The batching is nothing but the delay is nothing but linger milliseconds. Once you get the batch size worth of records, let's say my batch size is 10. So till I get the 10 messages for the partition, it will be sent immediately to the regardless of the setting. However, if we have a fewer than many bytes accumulated for this partition, we will linger for the specified time, wait for the more records to show up. Means my batch size is 10. Let's assume that I got only 6 messages. It will not send. It will wait for some time to collect other messages. Then it will send. If it's the time is lapse, the millisecond lapse, then it will send the messages. The setting will default to the 5 millisecond. For example, would have the effect of the reducing the number of requests sent to the add up to the 5 milliseconds latency to regard to the sent to the. So this is called linear milliseconds batch ID. What I'm trying to show here, different configurations. Okay, so here the partitioner class is default. We have a different kind of partitions. I have told you, right? So default partitioner, it has a round robin custom partition. We can create our own custom partition, right? When you create our own custom partition, we will set this property partitioner dot class. So let's say Vera partitioner I have defined my partitioner or Vera partitioner. I will specify here, so it's a Vera partitioner. I'll specify here the Vera partitioner. So that is called what I mean, that is called my custom partitioner. That custom partitioner name I'll specify here. My custom partitioner name I'll specify here. Yeah, is this clear?
Yes.
So this is how that message is linger for some time. After buffering it, try to. This is all completely producer. Let's assume that this is completely producer. Then it will send to the Kafka. Let's see, let's send to the Kafka. As soon as it sends Kafka, it will send acknowledgement, right? So in case of it is failed to send, it will fail to send. It will do the retry. It will do the retry. Retries the messages. So that's how sending the messages, retrying it. In case of any failure happen, it will do the retry. It will do the 3 retries. The retry attempts will be 3 times. If it's beyond 3 times, beyond 3 times, it will fail the message. It says that message is not received. If you're using your ACK, it will clearly says that whatever whether it's copy to all brokers or it's copy to only one based on your ACK. If it's ACK is one, ACK is all, so based on that. Yeah. So this is how your consumer publish the messages and write it. Any questions, please ask me. We will connect tomorrow and we will also see one more example with the multiple consumers, and I'll drop one of the consumer. So when I drop one consumer, we will see that see normally you have a consumer group, correct? You have your consumer group. I'll just give us some introduction here, then I'll move. I have one consumer here. Consumer. I have one more consumer. Consumer 2. Let me show you a simple example, then we'll wind it up. First, let me clear all of them because it makes. Okay. I'll start all of these guys. I will start one more consumer. 4 consumers I'm starting. Okay, 4 consumers are there. Consumer 1, 2, 3, 4. 4 consumers I started. I'm starting my producer, which has 3 partitions. You know, right? Which has 3 partitions. I started 4 consumers, but my producer has only 3. Let load 3 partitions. I'm running my producer. Look at here. This is started connected to the partition 2. It is not get any message yet. This is connected to partition 0. This is connected to partition 1. Means if you have more consumers than your partitions, one of the consumer will be idle. One of the consumer will be idle. This is what we discussed as part of our consumer group earlier, right? If you have
Yes.
more consumers than your partitions, one of the consumer will be idle. Let's say I have stopped one consumer. Let's say I have 4 consumers here. I'm stopping messages are sent. So I will do one thing. I'll increase the messages. Start this. Now we will see who are all getting the messages. This guy is getting message. This guy is not getting. Obviously, I think this guy will be getting. This guy also will be getting messages. Okay. Now I'll stop one of the consumer. I'll stop it. Now, look at this guy. He didn't get a message. Look at this guy. He's reading partition 2. Partition 2. Look at this guy. He's reading partition 0. Partition 0. Partition 0. That rebalance should happen. Yeah, this guy started reading partition 1 also. Look at here. Partition 1. Partition 2. It means both the partitions are dealing by this guy itself. This guy's, yeah, this guy started. Look at here. This guy was idle. This guy was idle. When he stopped on consumer, other partition tried reading only one message. Okay, that is only one message. This one. Few messages. Oh, no, it didn't read it. It's the old messages. I could have cleared it. Okay, so then whichever was idle, he picked up. Whichever was idle, he picked up. Then he started reading the message. Then he started reading the message. If I stop this guy also, it makes sure that other guys, other 2 consumers will rebalance and they will connect to 2 partitions. They will start reading it. Either of this guy or other guy. So see, this guy only dealing partition 2, partition 1. So this guy started reading 2 partitions. This is how the rebalancing will happen in the group. This is an advantage if we have a group. This is an advantage if we have a group. So if you have a four consumers than, more consumers than the partitions, one of the consumer will be which are the excess consumers, they will be idle. Whenever any one of the consumer goes down, other consumer will pick up and they will start read the messages. Okay. So if you have a less consumers, one of the consumer will connect to the 2 partitions and it will read. Okay. So that's it for now. So let's connect in the next session. We'll see in detail example about that. Any questions?
No, Ravi. Thank you.
Okay. Thank you. Whoever joined for next session, please stay there. Others can leave for the day. Okay. Thank you. Just